Ladies and gentlemen, good afternoon. First, I apologize for my English. I was informed that I have to make this presentation. It was too late to revise my English and pronunciation. And so I'll try to be as comprehensible as possible. Phosphorus is an essential and non-substitutable nutrient in plant nutrition, but tensions on the fertilizer market, price fluctuation last years, because the resource is non-renewable and demand is increasing worldwide. And to environmental risks, eutrophication liable to lead to stricter regulation. The current bases for phosphorus management are: a soil phosphorus availability is determined according to methods using chemical extractants, and vegetable crops are classified among the species with high phosphorus requirement. For example, for carotte crops, a no fertilization threshold is fixed at 70 mg phosphoric acid per kilo soils, all same methods in our soils, and input ranging from 100 to 150 kilo phosphoric acid per hectare. Trials were conducted from 2008 to 2010 in the Aquitaine region, the southwest of France, circa 50% of French production of fresh market. Different crop cycles, spring, summer, different cultivar, Romance, Nanda, Nansen, Maestro. So we make, during 3 years, 4 trials with different soils. You've got the information about the soils. Our soils are very sandy soils, 95% of sand and organic matter. You see that the cation exchange capacity of these soils are linked to the organic carbon content. Response to carotte crops to increasing doses in the yields. The first experiment we did was on fields with a P. Olsen at 87 mg phosphoric acid per kilo. And we obtained no statistical difference in yields between 0 to 320 kilo phosphoric acid per hectare. So it seems that the soil, the phosphorus in soil was sufficient to ensure the same production in all the plots. So it seems that phosphorus is not required every year. The years after, we make some more experimentation with soils with lower level in phosphorus Olsen, 23 mg phosphoric acid per kilo, and we found an optimum at 60 kilo phosphoric acid per hectare. So it was on a spring crop, but we made 2 on summer crop with identical results. On these fields, on these trials, we look to the pay consumption of the carrots. At the end of the culture, we have collected weight and analyzed plant, roots and leaves to know pay uptakes in relation to the doses. Without pay input, the zero phosphoric acid fertilization, it seems that the crop has extracted 17 kilo phosphorus per hectare. It has 35 kilo phosphoric acid per hectare. So supply from the soil can represent more than 50% of the optimum intake that we can see on the curve, 60 kilo. Luxury consumption, we see on the right graphic that up to 60 kilo phosphoric acid per hectare, the crop can mobilize more phosphorus than necessary. So the current basis up to now was soil pH availability, determined according to method with chemical extractant, vegetable crops that are with high phosphorus requirement, and for carotte crops, a threshold at 70 milligram phosphoric acid per kilo, and input up to now 100 to 150 kilo per hectare. This method is based on the plant's functioning. It's at the heart of the concept of such indicator. The penetration in plant is based on the uptake of phosphate ions in the soil solution. The soil solution is a transitory compartment, and the stocks are found in the solid phase. Resupplying the nutrient medium takes place through diffusion of the ions from the solid phase to the solution, with a concentration gradient of the solution induced by roots absorption on the phosphate ions. The soil supply E, the global soil phosphorus supply, is the sum of solute ions, the soluble ions, and ions liable to become solute, diffusible, called diffusible ions. The soluble phosphorus, called Cp, is the pH concentration measured in soil sample. The diffusible phosphorus, Pr, is diffusible phosphate ions in the solid solution interface. And the calculation is E is Cp per 10 plus PR. Application to carotte crops. The trial between 2008 to 2010 involved assessing soil supply during the crop's juvenile phase, sensitive phase, under increasing P fertilizing regime, 0 to 320 kilo phosphoric acid per hectare of super 45. Associating soil supply and yield index. It's the yield obtained with a given dose related to the optimum yield at 60 kilo phosphoric acid per hectare, and determining the response thresholds of the indicator. So, excuse me. If we report on a diagram the yield index in function of Cp, the left diagrams, we can see a threshold at 1 milligram P per liter. It appears clearly. The same work in function of E, the right curve, show a threshold at 15.7 milligram P per kilo of soil. So, in slightly buffered soils, Cp may be sufficient. And E is more universal indicator, whatever the soil, but for estimated IM, you have to require isotopic tracing and analysis during isotopic dilution that exclude from routine analysis. And the next stage is to establish pedotransfer function from the soil physical chemical characteristic, pH, texture, organic matter, cation exchange capacity, to determine this party. Benefits and limits of the new bioavailability method. Integrating fertilizing management based on phytoavailable phosphorus in relation to the plant nutrition, will give lower level of input. The indicator E, not dependent of the soil nature, contrary to the P Olsen, the phosphorus Olsen, but more research are necessary to obtain the diffusible P on the basis of the soil physical chemical characteristics. Pedotransfer functions currently under study at INRA Bordeaux. Indicator, Cp, may be sufficient in case on slightly buffered soils, like in the Aquitaine region, southwest of France, sandy soil, determined on a basis of simple water extract analysis and experimentally determined threshold at 1 milligram P per liter. To be validated in wider commercial production conditions, some trials are underway in Aquitaine with my association in Venio, experimental station. Conclusion and outlook: update in pay requirements of carotte crops, less than before, twice less as before. Innovative indicators, CPE, reflecting the root uptakes mechanism validated for carotte crops, and experimentally established threshold values, reference to be consolidated in wider agronomic production conditions. New practice already implemented in the field permit saving P without compromising yields, reducing the risk of phosphate pollution, and helps conserve resources. Data acquired from carotte paves the way for updating integrated P management for the other vegetable species. Thank you for your attention.
What are the ideas to continue this job in Aquitaine? What are the ideas?
We work on phosphorus since a few years, and we thought that the phosphorus is in too heavy concentration in the soil, and maybe carrots doesn't need such a concentration. So we are looking for new indicators to do that. It's why we began with this experimentation in 2008, and we work first on phosphorus, and now we work too on potassium.
Tony Moses from Australia. Just had a question in relationship to these phosphorus indicators. Is there any commercial adoption by farmers in relationship to using these to help establish their phosphorus or fertiliser requirements?
Up to now, we are only at the research stage. So I said you that the pedotransfer function is on the way at INRA Bordeaux because we can determine easily the CP, the soluble ions, but we don't have a look on the diffusible ions. It's a work, we have to work about this thing. But in the fields, the inputs were divided by 2 after this experimentation.
Thank you. Just further to that, has there been any surveys done? Sorry, has there been any surveys done locally through the carrot growing districts to establish what sort of soil levels of P there are, and whether there's a over fertilisation or in relationship to that carrot production? Thank you.
In our area, we make. In our area, they are very. It was before a pine wood, and the culture are only since 50, 60 years. So the soil are very low in phosphorus at the beginning when we take pines out. And as they are very acid soils, in the years 50, 60, 70, the growers give a lot scoring of dephosphorration to go up the pH, and this scoring give our phosphorus. So when we make some analysis, we have very hard. It was very hard to find soils with low phosphorus. It's why the first fields we make trial, where we make trials, was at 87 milligram phosphoric acid per hectare. For the laboratory, it was a very low level, but the experience with carotte show that even without phosphoric fertilization, the carotte can grow normally. So the experimentation made after this date was on very young fields, just after pine uptake, or on a special parcel of INRA, which is since 30 years without phosphoric and potassic fertilization.